Slow down. You're writing too fast.
Oh, man.
Okay.
Is this more examples?
Yes.
Not ready.
This is number 3.
It's number 5.
I'm just.
I thought that said a snowman with a spiritual head. I was like,
Maybe I thought it was only in the.
Uniformly.
so there's 4 samples today.
We're only doing 3. 2.
I mean, we didn't get through them when we ran the test.
Well, we also started late yesterday.
Yeah.
Barely, like 2 minutes.
We will see how far we get.
But I need to do the homework if we.
Well, if we don't get through all the examples, we won't turn the homework in on Monday. We'll turn it on Tuesday.
Can we work on it on Monday? Because it's pretty confusing.
That's probably what we're gonna do.
Monday, we're gonna work through it together.
I didn't say that, but our,
Together.
probably like a partner. Kind of
What did
chat.
you say?
What kind of
Partner
environment does a snowman melt this in? Is it like
In a
in an
controlled
oven?
environment.
Is it like in an oven or something? Where heat's applied to all sides? As if it's in the sun. Just trying to be reasonable here.
Okay, are we ready?
Yeah.
Are we all done writing? Because I don't want to start till we are.
Yeah. Oh, no, I'm not done writing. I was eating, but you can start.
Okay, so this problem says a snowman with a spherical head is uniformly melting at a rate of 3 inches cubed per hour. At what rate is the radius shrinking when the volume of the head is 50 inches cubed? So the first thing we need to do is what?
See what we have.
See what we have. What information do we have? What information are we solving for? So what is the first piece of information that I have about this snowman?
3 inches.
It's melting at a rate of 3 inches cubed, which means that that is the rate at which my volume is changing. So that's dV dt, and it is -3 inches cubed per hour. Negative, because it is getting smaller. What other piece of information do I have? The volume is equal to 50. And then what is the thing that I am solving for? The rate at which the radius is shrinking, which is the dr dt. Are we all okay with that? What happened?
No, I just don't remember simple equations.
Okay. So since this question is kind of centered around the volume of this snowman's head, I obviously have to know the equation for volume of sphere. What is it?
Yeah, it's not one. Is that 4/3 pi r cubed?
4/3 pi r cubed.
Oh. Why do I know?
What am I gonna do with that volume equation since I'm down to one variable on the right-hand side? I'm going to differentiate it. So when I differentiate the volume, it becomes dV dr. The 3 on my r drops down and it becomes 3 times 4/3, which is just 4. My exponent decreases by 1. And since I took the derivative of r, I have to indicate that I took the derivative of r with dr dt. So this becomes dV dr is equal to 4 pi r squared dr dt.
Please explain how you got the 4 again.
That multiplies out, and then
Oh,
the 3
okay.
and 3 cancel, leaving the 4.
I don't understand why we have to add in the DRDT.
Because I took the derivative of my radius.
Okay, but if we were just like had a regular graph thing and you're like
Wait,
taking the derivative of it, like that was an X, it's just not.
Right, but I don't have multiple things changing at the same time in a normal equation. So I'm trying to isolate just one specific part of it. And so I didn't necessarily care before, but here I care.
Okay.
Because each of these is affecting the other part of it. Okay, so the super duper awesome thing is that I have some of this information. What do I have?
One thing.
I have one thing, which means I'm still gonna have an R left, and I'm still gonna have a dr dt, which I cannot have. I can't have 2 unknown things left here, which means I'm gonna have to do something to solve for R, so I have a number to plug in here.
Do we even have one thing?
Yeah, we have technically dV dr is the same as dV dt.
Well, we put 4 thirds.
I know,
Why?
it is the notation because
I don't understand how
it's the
it's the same.
derivative of volume in terms of radius, but my radius was derived in terms of time. So it is the same thing.
No, it's not. It's not.
It is the same thing. I
I don't
promise
understand how
it
it's just like, I feel we're just pulling random crap out of
You
it.
said this happened.
I understand why we use those.
Yeah.
Okay, so just trust me that it is, and then at some point I will find a time and show you exactly how
Yeah,
it is.
but when I'm doing this on my own, I'm not gonna be like, oh, dV over dr equals dV over dt. Like, I'm not gonna be like.
Can we just
my
say
head
that if
is
it
not
has the same thing at the top, it's the
Then
same?
it's the same.
Fine, you can say it has the same thing in the top. For right now, it is the same until we understand why.
Always the same thing.
Okay, so as I already said, we have 2 unknowns on this right-hand side, which means I'm going to need to solve for one of them in a separate equation and then plug that value in. Radius is going to be the only thing I can solve for because I can't solve for a rate of change if I don't know any of the other information. So I'm going to write a separate volume equation in which I'm going to plug in information and solve for R. So the only thing I know about volume here is that my volume is 50. So I'm going to say 50 equals 4/3 pi r cubed, and I'm going to solve for R. When we do that, we get that R is approximately 2.2854 inches. I'm now going to take this R equals 2.2854, and I'm going to take this dV dt, and I'm going to substitute them into their appropriate place in this differentiated equation that we have. And it's going to leave me with -3 equals 4 pi 2.2854 squared, and then dr dt. And then I'm going to solve for dr dt. So I'd like for you to do that on your own right now. And then write down the decimal and we will compare. Solving for dr dt. Deanna, what'd you get?
What? Oh, no.
why I called on you. Devin, what'd you get?
This was like a really small number. I got negative 0.0457.
How'd you guys do that?
Everybody else get negative 0.0457. How do we solve it? I would have multiplied all of this together and done this divided by that. Did anybody not get that?
I'm trying.
Okay, if you didn't get it, try it again.
I got negative 21.
That one was ridiculous.
I got negative 0.
That one was hard.
I don't know if I did it right.
So it'd be negative 3 over. Oh, wait, where'd that
And-
square come
The R squared right here.
Negative 3 divided by the ends.
When I was doing this problem, I felt like I went grocery shopping, and I was like, I'm not gonna get that much. I don't need a cart.
I get
But then you end up getting a whole lot, and then you're like walking around the store like this, and you're like trying not to drop anything. That's what doing this problem is.
That's a very good comparison.
In other words, problem sucks.
Okay, are we ready for the next one? Okay, I'll give Deanna a second.
Yeah, I got it.
Okay,
Negative 3 up arrow. All you have to do is negative 3 divided by the ends. The problem's answer. Up arrow. She was doing the carrot, not the up arrow.
I think I'm gonna like this one
why do you think you're gonna like this one?
because it's the surface area of a cube, and that doesn't involve directions.
Are we all done writing? Okay, so this problem says the surface area of a cube is increasing at a rate of 18 inches squared per second. How fast is the volume of the cube increasing at the instant when the surface area is 54 inches squared? So, what'd you say, hon? Yeah, it's just another way of saying time.
That makes it sound like we need an exact number and it's still approximation.
I just
So
keep
I don't
thinking
like
that
that word.
instant.
You can say instance, instant.
That was, are interchangeable.
Depends on how you word it, but yeah.
We need the volume too.
Yes.
I don't like just like.
Okay,
saying that.
So let's pull out the information that we do have here. What do I know?
Increasing at a rate.
What is increasing at a rate?
The surface area.
Okay, so I know dSA dt.
Three letters.
Yes, SA is always surface area. So I know that my surface area is increasing, so it's going to be a positive 18 inches squared per second. I know the surface area is what?
4 inches squared.
Perfect. And then what am I trying to find?
The volume.
So the change in the volume. So dV dt. I have a question for you. Is there any equation that connects surface area and volume of a cube?
I mean, probably.
Not directly. So we're going to have two equations that we're going to be working with here.
They could be.
Not directly.
How?
Not directly. Okay. So the first equation I clearly have is my volume equation. How do I find the volume of a cube?
Side of like cube.
Length times width times height. It's a cube, so all my sides are the same. So it's s times s times s, which is s cubed. Right? We're all okay with that.
Yeah.
Never mind.
Okay. My second equation then is going to deal with my surface area. How do I find the surface area of a cube?
6s squared.
S squared times 6. So I take the area of each of my 6 sides. The area of a square is s times s because the length and the width are the same. So I have s squared and I have 6 of them, so it's 6s squared. Sometimes it helps to draw a picture. You don't have to, I'm saying it could help. Okay.
No.
So this is the one that I'm going to be using to actually answer the question asked in the problem, but I'm going to have to use this one to get that answer. So I'm going to start by differentiating this and seeing what I need to fill in. So when I differentiate this, I take the derivative of v, and that's dv dt. Then I take the derivative of my s cubed, which turns into what?
3s squared d.
df dt, yeah. So I have 3s squared ds dt ds, because I took the derivative of an s.
Have it, yes, man.
That's okay. It is.
Yes, it is.
No, they are different. Okay, so this is what I'm solving for, but I can't solve for it now because I have an unknown s and I have an unknown ds dt. So I'm going to use my surface area to solve for that unknown s and that unknown ds dt. Well, in order to solve for an ds dt, I have to take the derivative of an s somewhere. So I'm going to have to derive or differentiate my surface area equation. So let's take the derivative of this because I have some of the information that's going to plug into it,
We also have the surface area, so can't we just?
but I don't know s, so it's not going to help me.
We can just solve for s.
We're going there. We're going there.
We have to take the derivative.
Don't argue with me.
I don't understand why.
Don't argue with me.
I don't understand why. If you explain why, then I will argue.
Okay, so what are you saying?
We can just plug in the 54 in the surface
I never said
area.
we weren't going to do that.
But why would we need to take the derivative? We can just solve for s right now.
But then we're doing the same thing. We're just doing it in opposite order. So does it really matter which one we do first?
I don't know what you're doing. Why would you take the derivative?
Because I have to solve for ds dt. The only way to do that is to take the derivative of an s. So that I can plug it in here. So I have to differentiate this. I have to. Otherwise, I will never have a ds dt to plug in. Okay, well, I guess. Where did I lose you at? Because I'm more than happy to go back and look.
No, it's
So
fine.
DS
It's just,
doesn't
keep going.
equal
No,
to times
I understand. We need the s because we have to plug it in, so we're solving for the derivative of s, not s.
We will solve for s as well, but not in this
right
one.
now.
Right. Okay. So let's differentiate this. So when I do, I get dsa over ds equals 12s ds dt. Right? I just took the derivative of that whole thing. What's wrong?
No, I'm just stupid.
You're not stupid. Don't say that.
I wrote 6x cubed.
I know what the derivative of my surface area is, right? I know the rate of change. What is it? 18, so I'm gonna plug that in where my DS is. And now I've kind of run into a stop because I have an unknown S and I still have an unknown DS dt. But as Devin pointed out, I can solve for S by setting up another one of these surface area equations, plugging in what my surface area is and solving for S. So I'm gonna do that. I know my surface area is 54. And now I can easily solve for S and I can plug it into both of these all at the same time. Divide each side by 6, I get 9 is equal to S squared. What's the square root of 9? Why am I not using -3?
Why would it be -3?
S is the length of one of my sides. Can I have a negative length?
No.
No.
Why would it be negative anything?
Well, square root of 9 is not just +3, it's also -3. So make sure you're keeping that in mind and we are eliminating based off of the appropriateness for our problem. So I have that S is equal to 3, so I can take that and I can plug it into both of these derivatives that I have calculated. Now the super cool thing is, in my surface area derivative, my only unknown now is ds dt, which means I can solve for ds dt, and then I'll plug it in to my volume derivative and finish solving out my problem. So when somebody has an answer for what ds dt is, let me know.
I got 1/2.
1/2. Because you get 18 over 36, which reduces to 1/2 or 0.5. I'm now going to take this ds dt that's equal to 1/2, and I'm going to plug it in where the ds dt was in my volume derivative. And then I'm going to multiply all of this together and get what my rate of change is for the volume. What do we get? Or 27 over 2. I will do 13.5. That's your answer.
Hey, why'd you put that it equals that? Doesn't surprise me.
Actually, that came out even. Because it was 27 over 2. It wasn't a decimal that continue on.
Every other time you said that it doesn't equal that, I want to written like this, and you made it.
But it did equal that. It came out exact. I didn't have any rounding in here anywhere. So I didn't have to put an approximation. I didn't round any of my decimals. I didn't take it out to 4 decimal places and round it. So it is an exact value.
Like we had to have some.
If you put in approximation, of course, I'm not going to count you wrong because you're used to doing that, and that's okay. But know that I didn't round at any of these things, which means that is an exact answer.
So what about the unit?
Okay, so the units really are not a big deal. But if it was volume, it would be inches cubed per, and then whatever my unit of time is, second. I'm more focused on the process right now, rather than just filling in something really easy like units. What's your question, Corbin?
Nothing. Just thinking.
Okay, but it definitely doesn't hurt you to think about units as you work through these
We have to do units
on the AP test or on my test.
on your test.
No,
Most
I'd be
likely
okay.
on
I'm
the-
more interested in the process.
And then on the AP, most likely.
On AP, yes, but we have plenty of time to prepare for that. Okay, did everybody take a look at this problem and understand each step that we did? For the most part,
Semi.
for the most part. Deanna, how about you, honey? Did you understand what we did here? Devin, did you understand what we did here?
I'm gonna say yes.
But you don't mean it.
Exactly.
Okay, well, what don't you understand?
I just like, you're just writing down numbers and like giving them like dv, dt and all that. I'll figure it out, it's okay.
Like I'm perfectly fine doing it in class, but I'm never gonna be able to.
Yeah.
Which is why we are gonna do it in class on Monday, but you guys are gonna work together.
Because like you're pulling out like equations and crap. that I
Yeah,
don't
that's
even
the
know
thing.
where.
Well,
they're
you're
at.
gonna have to practice these. You have to know these.
No, I understand that, but I don't
Okay.
understand why, like, I don't know where they came from,
Like,
or why you decided to use them.
When,
Well, I decided to use them because I talked about the surface area of a cube and I talked about the volume of a
This one
cube.
wasn't
And I
fast.
understand that,
It was
right?
when they
like
do the
three
AP
ones.
test, will we have to know all volumes?
You do not get a reference sheet.
Well, it's fine, I'll be in here for.
Well, we're doing them on Monday.
So we'll have to know volumes of stuff.
Okay, so that brings up another important point. When we finish all of our material, I'm gonna give you something called your need to know packet. This is gonna be all the information, like formulas that they can throw at you. You do not get a reference sheet for the AP exam.
Cheat sheet.
No, you don't get anything.
They know, how do they know?
Well, Miss Richards will sit here and watch you take it.
Who?
Miss Richards, the guidance counselor.
If I get.
What is she gonna do? What is she gonna do?
Well, she will invalidate your
I
test.
will pay her off.
That's fine. But I will give you like
Yeah.
the big ideas and need to know packets, and we're gonna have those through all of the AP prep.
Is that different than the packet you gave us at the beginning of the year?
Yes, those were just like trig references that you can go back and look at. So this will be different. It'll be all the area, volume, surface area equations they could possibly throw at you. It'll have all the trig stuff on there that you have to know, all of that. It'll be all encompassing, okay? So you will get that in February. I might even give it to you sooner as long as you promise not to lose it and to promise to bring it when we do our AP prep. But it's gonna have all of this stuff that you will have to memorize. Okay?
Yes.
Yeah, I know.
Yeah, why did you switch colors? I feel like that's what threw me off, I'm sorry.
I don't put that much stock in colors. I'm sorry, I should.
You literally
I know that
just switched
you-
colors in the middle of.
I know, I see that.
You switched it to do like the volume and the surface area and I understood that, and then you just started throwing it all in.
I'm sorry, I will try to use my colors in a more meaningful way.
You normally do.
I know, but then I get kind of carried away and I forget which color goes with which
What's
thing.
going on right now?
Also, has anyone else noticed that this year she's been flying through notes and she just talks super fast?
I don't.
You guys can tell me this. I will slow down.
No, it's been going
No, we just
so fast.
This year, we haven't actually had like notes, it's just been
Boo.
examples.
Okay. You guys, like he didn't just see you put them all on. Cylindrical.
Cylindrical.
It will be in your big ideas.
You're gonna put the word cylindrical.
I will, and I'll show you exactly what I mean.
I think you just made me confused.
Maybe I did. Maybe that's the whole point of this problem.
Well, why is the word
I found
cylindrical
that
so
any
confusing now?
for a cylinder that I've ever seen. Already.
You've been writing out a lot of cool words
I know.
since we started this.
I realize after I write it, I'm like, I could have just abbreviated that. That's fine. It's good practice, right? Works out the arm strength.
Especially inches. I'm not sure if you abbreviated once.
Well, then you think it's in, and then it just gets even more confusing. I like to switch it up once in a while.
Why?
So I'm gonna assume we're ignoring water disproportion.
Yes. Yes, we are.
What are we ignoring?
Go ahead, Corbin.
Water disproportion.
We're assuming everything is acting in a uniform manner.
Corbin, the fact that you would ask that.
There's lots of things we have to ignore. Okay, are we all done writing? Except for Devin? So this problem says, a cylindrical container is being filled with water at a rate of 18 cubic inches per minute. The container has a radius of 3 inches and a height of 20 inches. At what rate is the height changing at the moment when it is filled to the 5-inch level? So as I'm looking at this, what's probably the first thing I'm gonna do? Even better. I'm gonna draw a picture. Because there's gonna be a lot of variable stuff happening here. And I'm going to want to know what this container looks like. So I'm gonna draw a cylindrical container, which is a cylinder that has a top and a bottom. It's as good as I get for 3D.
My brain hurts. See you guys later.
So yeah, I know this cylinder has what? It has a height that is 20, so I'm gonna go ahead and say that that's this one right here. I know, and and it has what? It has, let's focus again. What information do I know about the cylinder? It has the height of 20 and a radius of what?
3.
3. So I'm gonna wanna draw that in here.
Oh shoot, I made my picture too small.
My picture's a lot smaller than that. Maybe it's not.
Look how amazing my cylinder looks. It's pretty great.
How big is your
Look
cylinder?
at that.
My cylinder is non-existent so far.
Oh.
Actually, my cylinder is. I only draw shapes in there.
Okay, so I have the approximate dimensions of my cylinder. What other information was I given in this problem?
Where it's built to.
The rate at which my container is filling, correct?
Yes.
Okay, what is that rate? 18 cubic inches per minute. So I'm gonna say that's my volume. So the rate at which my volume is changing is equal to a positive 18 cubic inches per minute. What am I solving for?
What rate the height is changing at the 5 inches of it.
So I'm solving for dH dt. That is going to be my unknown.
Are we like writing down the 5 over here?
Okay, we're not forgetting about the 5. That 5 only applies when I'm looking at the height, or the rate at which my height is changing when the height is 5. So this H is only going to apply when I do this, for the most part. So what formula do you think I'm going to start with?
This volume of the cylinder.
Volume of a cylinder. Anybody know what it is?
Higher squared times height.
Pi r squared times height. So it's the area of a circle times the height of the cylindrical tube.
Which height would we use?
We're going to use just H for right now, and then I'll show you. So pi r squared H.
Well, we can calculate. the
Well,
volume.
8 R's, we know.
We know all the variables in the problem. Okay, so
I love that you guys are theorizing. It makes me so happy.
Can we not?
So incredibly happy.
that's why she's happy.
You're wrong.
She's like, that's why it's
We're trying not to use it for it.
I don't actually want you to differentiate it yet. What do I probably want to plug in before I differentiate it?
The H and R.
How about the thing that remains constant through this entire problem? So the R.
Pi.
The radius of my cylinder is unchanging. So we're going to go ahead and plug that in before we differentiate. So when I do, I get V equals pi times 3 squared, which is 9, and then the H, of course, is still there. Or you could rewrite this as 9 pi H.
Yeah,
Your
I'll
choice.
write it as
I would too. Now I'm going to go ahead and differentiate this equation.
just H.
When I differentiate it, what's going to happen? dv over
DT.
dh, because
What?
h is the variable left on the other side. Equals, we treat 9 pi as a constant times my variable h. So the derivative of 9 pi h is 9 pi. Just like having the derivative of 3x is 3. 9 pi here was just that number out front. And then times dh dt.
Usually, as you do more and more problems, you start to like get comfortable.
But these are also different. I'm just trying to show you a broad spectrum of problems.
Yesterday,
I do get it a little bit.
Well, I mean, I understand sometimes, but that's still.
Okay, do I have any of this information?
Wait, aren't you solving for DHDT?
I am.
Oh.
Do I have any of this information?
DVD.
I have dv dt. I know it's 18, so I'm gonna plug that in. And 18 is equal to 9 pi dh dt.
Yeah, you put dv over dh.
oh, because it's got the same.
We've done this before. Because it has the same top, I can plug it in. Because dv dh, and since h is in terms of dh dt, it's technically dv dh dt. So it all works, I promise.
Boy.
And then we solve for dh dt.
That's the hard
Six.
part.
Whoa, I got 6.2.
I would have done like 2 over pi. I got 8 points.
Wait, what?
Solving for dh dt.
So 18 over 9.
So 2 over pi.
2 over pi.
Yeah.
I got 0.6366.
That's bad. Alright.
And this would be squiggly lines, alright?
Yes, this would be an approximation.
Okay, but why is it different when I put an 18 over 9 pi? Why is that?
Are you doing 18 over 9? Are you putting a 9 pi in parentheses? No. Do that first.
Otherwise, it would do.
Because if not, it's doing 18 divided by 9 and then multiplying your answer by pi.
You know what? I hate
Calculators are stupid. No, they
Or
are.
they just follow him, though.
I got it.
It is well, it's
Okay, would you like to do the last example or would you like to wait till Monday?
Wait.
I don't wanna do it.
How big is it?
I'm not working on this homework. I'm telling you that right now.
You know what?
I'm not. I just need a
Okay,
break.
how about we write down the problem and then we'll solve it on Monday. That'll save us some time. It is maybe the longest problem we've had to write.
And I only have a quarter of a page left.
I have, yeah.
Wait, how long?
That's how long to write it.
Oh,
That's
how
just
much
to write it?
registration have.
Wait, that's not-
That was just, like, that's just writing.
Oh, okay, never mind. I thought you meant the whole bottom.
I didn't write real big on this one.
Okay, but I have the same amount of numbers.
That is a whole like paragraph.
If I write really tiny, maybe I can fit it all.
You can repeat it.
Yeah, but.
Conical? Conical.
Conical, which is a cone, yes.
Water.
That's what I was about that.
Like, yeah, no one's sleeping.
Why is that blue?
Because that's the way this water tank is.
They made it like this, they didn't have to find like a wrap.
Is it like a filter almost?
Stick it
It-
down.
Looks like one.
Oh,
Uh,
there an alternate?
No.
Are you recording?
Yes,
Is your mic on?
yes.
Oh, so we'll all hear ourselves say.
Yeah.
And Bobby just stares off.
My brain hurts.
I was like,
I just said scooter, I couldn't get it out of my pocket.
and then he's like jiggling the keys. It's like that last second. I was like, not
I feel like he takes the key and then shakes the keys for a while just for fun.
like, why doesn't he just knock on the door? He really does.
Yeah, I'll scroll it up.
Good morning, KHS. Here are your announcements for today, January 8th. The last day to order captain gowns and other senior items is Tuesday, January 12th. Seniors have been sent an email instructing you on the process. If you have any questions, we'll find the athletic office. During screening for sophomores and new students will be Monday. Testing will be done during science class. Winter homecoming is next week. We are doing a dance with the stars. Each class will be doing a dance based on their theme. Please see class officers or class sponsors if you'd like to help.
Each class will be doing a dance based off their theme.
Here is Thursday.
Yeah,
Stop
don't ask.
on the grounds in the morning to check the eye for your defense. Rally Monday.
What the heck is our? I know it's like.
Except Tuesday, lessons, lines, and instruction. Hip hop comes day. When they originally landed, that's the whole reason why they were. Last summer, we had They didn't ask anyone else, they just lowered it. Oh my, it's also the answer. Yeah, but they let it Kurt run. Kennedy were originally saying that they feel that it will do for next week, talk, so it's about the dogs and auto check and provide. Juniors will meet with them on Monday during effort.
Okay, so this problem says the conical water tank is leaking from the bottom, which is its point. The tank is 100 feet tall and has a diameter of 50 feet. The radius of the circle of the water surface is changing at a rate of 2 feet per day. At what rate is the volume of the water changing at the time when the radius of the surface of the water is 15 feet? And of course, we're gonna do this one on Monday.
Education, the opportunity to earn.
Yeah, that legit took out all
About
the.
$7,500 each year before academic year. The deadline is January 31st. Please see guidance and questions. Grow Ag Leadership Scholarship